Hello there, Cardinals. It's me, Mr. Ernst, and today we're going to be once again using the Pythagorean Theorem. This time, we're going to use it to find a missing hypotenuse. On our triangle down here, we have our two smaller legs. We also do know for sure this is a right triangle, which is good. We have our two smaller legs, but we have no idea how long the hypotenuse is. The Pythagorean Theorem is something we can use as a basic equation, plug-and-play equation, to figure out what our hypotenuse is. So, we start off by plugging in what we do know. And in this case, what we do know is the two smaller lengths. So this will be 3 squared plus 4 squared is going to be equal to, and we don't know what c is, so it stays a variable, c squared. Now I can simplify these two. 3 squared is going to be 9. 4 squared is going to give me 16. And once again, I can't do anything with my c squared because it's still a darn variable. So that's still c squared. 9 plus 16 are going to simplify out to be 25 is equal to, still nothing happening with that c squared. So we have 25 is equal to c squared. But we are not done yet because we are not looking for the entire square that comes off of this side. We're looking for just this side length. So we have to find the square root. So I got to take the square root of 25, and if I do it to one side, I have to do it to the other. This is going to cancel out this square. The square root of a square number is going to cancel each other out, kind of like multiplying and dividing at the same time. So now this just becomes basic old c. It loses its square. And the square root of 25 is 5. And now we have our answer. C, our hypotenuse, is equal to 5. So this number is 5. Let's take a look at one more example. For this red square, we have 2, 3. We're going to fill in the exact same thing. Again, fill in what we know. We know the two smaller sides. The side is going to be, we'll have 2 squared plus, this is 3 squared, is going to be equal to, again, this is a variable, so this is just going to stay c squared. I can't do anything because I have no idea what my hypotenuse is. 2 squared is going to be 4 plus 9 is equal to c squared. Again, have no idea what this is. 4 plus 9 is going to give me 13 is equal to c squared. And I'm not done yet because I want to make this just regular c. So I have to take the square root and take the square root. That gives me regular old c is equal to, and here's a tricky thing, 13 is not a perfect square. It's not like 25 where it's going to come down to a nice clean number. So I'm going to have to either estimate it or put it into a calculator. You can also leave the answer like this, the square root of 13. That is an acceptable answer, so you could take this and write in the square root of 13 is probably the most accurate answer because you don't have to round or anything. So square root of 13 works, or if you want to get your calculator, type in 13, find the square root of it. You're going to get, looks like 3.6. What was it? Hold on. 3.605. So another acceptable answer, if you did want to simplify it into a decimal, would be 3.605. Let me double check that one more time to make sure I'm not giving you a wrong answer. Yes, 3.605. Actually, wait. Oh ho! This actually rounds up. The next decimal after that was going to be a 5 anyways. So both of these would be correct answers. Oops. 13 is equal to the square, or c is equal to the square root of 13, or c is equal to 3.606. So this could be square root of 13 or 3.606. And that is how you use the Pythagorean theorem to find a missing hypotenuse. Thank you for watching.